there's a lot of friction where they're optimizing for certain aspects or certain parts of their pipeline where we're optimizing for ours.
Yeah.
So there's definitely one friction point there, I'd say. Do you ever notice that in your workplace?
No, I'm just noticing that you guys all have frictions with data scientists, so I'm like...
Hi, I'm Shubhi, and I'm a machine learning engineer at SurveyMonkey.
Hi, I'm Esther, and I'm a data scientist at TaskRabbit.
Hi, I'm Justin, and I'm a data engineer at Fire.
In my mind, I think a machine learning engineer kind of sits in between the tasks or work that a data scientist and a data engineer would do. And that's not to say that they are the all-in-one, they do both, but they end up acting as the glue between the work that data engineers and data scientists do. And depending upon the size of the company, you might see machine learning engineers that do all three, or machine learning engineers that fit in more tightly knit and having more of a niche in there, where data engineers are in charge of data pipelines and data scientists are in charge of developing the models that are used within a product or something like that. What do you guys think?
I agree for the most part. I think I definitely agree with the data engineering definition where it's mostly about the pipelines and like just grabbing all the data into like this beautiful data architecture so that data scientists don't have to worry too much about it and can just use it to develop models. The difference between a data scientist and a machine learning engineer, to me, that's the one where I see the most blurry definition.
Yeah.
Probably the way I would define it is machine learning engineers just write a lot better software engineering code. They're just a lot like have more like DevOps maybe some DevOps and a lot of knowing about how to put models into production. So I think that's the main distinction.
I agree with that. I guess to clarify more on the data engineer part, one big difference I think is we emphasize a lot of reliability, scalability, robustability. So like things that making sure that the system is reliable and robust. One other point is also we usually are the platform engineer too. So creating a platform for you guys to work on, making sure that the data comes in where it's needed and in the proper format. So I think that's also one layer of data engineering that's also important.
Yeah, that makes a lot of sense. And something that I've been doing a lot lately and I've noticed a lot in the industry is that there's that concept of an ML platform that sits on top of the data platform, right?
Yeah.
And like that's slowly starting to come into play more as ML models scale out within enterprise. So kind of like what you talked about, the robustability and scalability and the DevOps or the architecture part of a data platform. I find that there's often days or slowly it's starting to become more realistic to have an ML platform that sits on top of that, that provides the same qualities, but more on the ML side of specific to standing up ML models or ML model services.
So now that you mentioned scalability, it's making me think that, that's also like a big difference between a data scientist and a machine learning engineer. I think a machine learning engineer has to worry more about like, is this going to scale? Like, how do I even like train this model like in a way that where my data doesn't fit in one place, but it has to go into multiple places. And I think that will fall more into like the machine learning engineer. The data scientists probably focus more in like solving the solution, but sometimes thinks less of is this gonna scale or is this gonna be deployed? Which not to say that they probably should still think about it, but they probably think less about it.
Do data scientists ever have to worry about making something like production ready?
I would say, in my experience, they never have to worry about making things production ready.
Really?
I think it depends on the size of the company. As for instance, myself, when I was the only data scientist at the time at TaskRabbit, I actually did the deployment. Probably not with the same level of quality that machine learning engineering would. So I think as the company grows, there is more distinguished. My question is actually, having really not worked with a machine learning engineer and kind of like stepping into that direction myself, like, are the data scientists building the models and then somehow handling the models to machine learning engineer to like you put it in production? How does that work? That's
like actually a really great question. So at SurveyMonkey, and in my experience of talking with other data scientists and ML engineers, that's exactly what happens.
Okay.
We have a handoff process of, all right, from the data science perspective, this model is performing well, it meets all the business requirements. Now the next step is putting it in production. And there's already been several discussions prior to this handoff of how this model is going to be used, or it's thinking about being used. And so there's already some sort of mind, like from the data scientist mindset, there's a goal in mind, and then there's a handoff of all the artifacts, I would say, like the model itself, the training code, the prediction code, where the data came from, where the data results are stored, etc. And so that happens, and I don't think that's the most frictionless process right now.
No, I can see a lot of friction.
But I think people are coming up with new tools and processes, kind of like how Agile changed software engineering. I have an idea. I have like a thought that maybe something will come around that changes that handoff, or maybe we'll realize we don't even need it at some point. We'll see.
Yeah, I do think there should be like a better way than just like, but definitely not for data scientists and machine learning engineers to work in silos.
Yeah.
I think because the same way that when data scientists participate in Kaggle, these big companies are doing these Kaggle competitions, and like, the data scientists are trying to get the best score, but at the end of the day, a lot of the times the companies say, actually, we're not going to operationalize this model because it's so complex that it makes no sense to put it into production. So that's like where I can imagine if they work silos, this data scientist is going to build like this most amazing complex model that then if they hand it to you, you're going to be like, I don't think this is going to work.
I completely agree with you. And fortunately and unfortunately, I've had experiences like that as well. So there definitely has to be really close communication between the two on any project, really.
Mm-hmm.
Yeah.
ML and data scientists are typically like more closely coupled than data engineers. Data engineers pretty much provide the platform for you guys to run wild. So if a data engineer is doing his job right, I would say there's very little discussion between our groups, actually.
Mm-hmm.
The line is a bit more clear between data engineers, I would say.
The way I work a lot closely with the data engineers is that as a data scientist, we're the ones looking at the data the most. So we're often going to find like irregularities or like something is suddenly null or like it's delayed or like, so I feel like I always go to the data engineers like, hey, like...
Actually, you're right. I kind of take that
there's
back.
Something wrong here.
Yeah, data scientists often are the ones that are telling me that my transformations are wrong because typically we're at the front end of the pipeline. So whenever you have large amounts of data, you need it to be clean, sanitized, great for any PII data, personal data. A lot of that happens with basically data scientists telling us how to perform those transformations. Yeah. So I actually see that a lot in my work. Yeah.
I also work with data engineers in a similar kind of way, but more so not focused on, maybe you might be looking at training data or for training data, but for production pipelines, where we're building pipelines that utilize a lot of the pre-processing work or the processing work that you've built out in your own data pipelines. And since they're specific to ML models, we find that we have a lot of discussions of how we can best integrate our ML pipelines to fit with data engineering pipelines, since they rely on data as input and sometimes data as output as well.
Mm-hmm. I think that kind of goes into like us providing a platform for you guys to use so you can implement whatever they give you much more seamlessly. So yeah, I agree with that. This one's a silly one. I think I should start first because I'm at the start of the pipeline. So you're going to get a lot of data about zombies and possibly humans because you need to compare the two, right? Mm-hmm. What I would be doing is probably be ingesting the data, cleaning it, transforming it to something that's apples to apples comparable so that you guys can run your machine learning models on. I would also be in charge of probably making the platform very reliable and scalable, be able to ingest like millions of data, like you have like a record per person or creature. Mm-hmm. So I'd imagine I would be the one making the system as a whole more reliable. That would be my contribution.
Yeah, and once the data is there available for me, I would start exploring. As a data scientist, you need to start exploring what's available to you, what you can use, what you cannot use. So for instance, like I wonder if there was some data between like the smell of a zombie versus a human, that could be like a good feature. So like start thinking about the data that I have so that I can start thinking of features and models to just kind of build that like classification or whatever model I'm building. So yeah, that would be, I think, the most fun part, to build that and see how good or bad I can do it. And then once I feel like I have a good model, then I would start my conversation with you, like, hey, let's make it available so that, you know, like we can...
I completely agree. I might actually say we might have our conversation a little bit before that.
Okay.
Because when you're working on trying to determine, like when someone's going to start using this machine or something to determine whether someone's a zombie or a human, or detecting whether someone's a zombie or human, we have to make sure that the data pipeline that he made has the same amount of data available in the device. Let's just say it's a mobile app that you just scan around that's collecting all these features. So let's just say that he's able to give you something like smell that a phone can't give you.
Yeah, so we need the smell to be a real-time feature as well.
Exactly, because I'm positive we want to be able to tell whether someone's a zombie or human, like real time, like less than a second kind of thing.
That would be ideal.
And then I would be really involved in kind of understanding, like, okay, we have this model now, what are the requirements? Do we need it to be able to scale to like where millions of people will be using this app in order to detect zombie versus human? And how can we make it available via some sort of web service? Maybe internet doesn't exist when a zombie apocalypse is happening, so it needs to be existing only on the phone itself. So then I get into the business of, all right, let's make this model a lot smaller so it fits on a phone, doesn't have to call the internet or some sort of API in order to detect whether someone's zombie or human. And I guess various different parts like that before we make it available. But I wouldn't care about the mobile app. I wouldn't care about the whatever or how it's actually being interfaced to the end user. Probably just the back end part of that.
Oh, very nice.
Yeah.
I think we have a good team here.
Yeah, I think we could do it.
Maybe. Kind of get into the office, and I pretty much code. I collaborate a lot with machine learning and data science for the transformations. My day-to-day can also look, because we're a really small company, I need to ingest data directly from our clients. So a lot of it is also making our system more reliable, and if data comes in late or it's corrupted or it's just downright bad, I have to call them up basically. Some days we're put on a PagerDuty schedule, and sometimes I actually get ringed because we have jobs running over at like 4 in the morning.
Yeah.
So my day sometimes looks like waking up at 4 to, fix those issues or whatnot. And then,
Wow. What about the languages you use? Because you said you code a lot, but...
Yeah, Java is really popular. I know a lot of people use Scala for Spark.
Distributed computing.
Yeah, exactly. At my company specifically, we do a lot of Python. We're a Python shop. Yeah.
Oh, very nice.
What about you guys? What languages do you guys?
My day-to-day is kind of like 70% Python, 30% SQL for like on-the-spot data analysis. But for like more advanced analysis and machine learning, definitely Python. My day-to-day is like goes from like telling data engineers, please fix this this transformation or make this new transformation for me, to also participating with the product team, like talking to the PMs, the engineers, if they are like in the process of building a product that has some machine learning aspect, and kind of like trying to like get into an agreement of what that model should be. That's my day-to-day. I really like it. What about yours?
For me, I want to say it's split between talking with data engineers, data scientists, and I might be involved in the product manager or software engineering discussions, especially when we're trying to kind of roll out a new feature or roll out a new product. the back-end APIs or services have to handle whatever the front end is expecting or UI is expecting. But I want to say it's kind of like a combination of your work. I do end up using a lot of Python. Instead of using Scala, I'm using PySpark as well for these huge ML pipelines. Along the same time, we're also like building out our ML platform, so that ends up looking really like a lot of the same tools and technologies that a data platform might look like. But then we actually want to have our ML platform be kind of a UI for data scientists in the future. So we do some front end too, and that's pretty fun to dabble in that a little bit. But I would say a lot less SQL than data scientists. Like I kind of take it as hand, like, oh yeah, data scientists came up with the SQL. Like, that's fine for now. We'll come up with something else later, but we probably end up writing it in PySpark because it can handle the distributed joins and computations.
Do you ever go deeper into the infrastructure or like anything low level around that area? Or like...
So we do a lot of infrastructure and DevOps as well. Yeah. But like, yeah, we write Docker containers and manage Docker images and stand up like Flask services or Django services depending upon what's needed. So, but I still think that we still try to be a Python shop mostly.
Yeah.
So even though it's that, we default to the Python interfaces of that. So as an ML engineer, I don't have to keep on switching languages while switching frameworks too.
I see.
Yeah.
You mentioned something that I kind of want to ask. Maybe it's kind of getting out of the question, but like you mentioned Flask and Django. I'm very familiar with Flask. I love it. Can you explain the difference between Flask and Django?
Yeah, sure thing. In my view, Django is more fully loaded to be a proper like web app, and people do use Django as like backend APIs as well. But the whole idea is Django manages things like authentication, ORM, and I don't know, several different components of what you might have for a web app. Whereas Flask is more bare bones.
Okay.
It just gives you that straight up like, here's like an API kind of interface, and you can add on plugins as you fit, as you see like you want to add on to it.
So if you wanted authentication, you would get like a plugin for authentication, and then you'd put it in a Flask.
Versus in Django, it's already there. And so in that way, it's like a little bit of a larger, it's like a dinosaur versus like the smaller components.
Which do you prefer? Because I feel like if you have more control over what plugins and you have just a better understanding, like you can build a more complicated app probably to what you need, right?
Yeah, that's true. The way I view ML generally being used, though, is kind of in two categories. One is like your real-time stuff. So you need it stood up almost as like a microservice, whereas its own API. And since we are already calling it a microservice, at that point I would use something really small like Flask. But there are actually even smaller tools out there like that focus solely on really fast back-end web APIs that I might look into as well.
All right.
And for the big ML pipelines, that's where I deal with PySpark and use spinning up Airflow clusters to manage my ML pipelines that might run on AWS. And that's like a totally different ballgame.
So it's PySpark, not well suited for real time. It's more like near real time kind of thing.
So that's, I guess, a difficult one to answer in my view, because you also have something called Spark Streaming, which allows you to do like the real time transformations that you might be really familiar with too. But usually, in my experience, you can do both. It really depends on what the requirement is from like, the end user.
Very cool.
At my company, we actually use Spark Streaming, and PySpark. We tried to use PySpark, but we were finding that there were a lot of features on the Java versions that are not available in the PySpark versions. So because of that lag, we decided... Also, the community doesn't seem to be improving. They're not keeping up to date with the Java versions as well as my company would like. So we decided we're just going to use Java. So right now we're kind of running both Java and Python, which is... My boss is like, but it's just what it is, right? If you want the features, you gotta go with the language it's supported on.
Totally. If you know, as a data scientist who wants to like kind of like be more full stack and be in like do a little bit of data engineering, but also the machine learning engineering part, that's where PySpark sounds like very approachable because data
Yeah.
scientists are mostly always just writing Python. So like, I think that's what when it's suitable. But I understand that if it's behind, then you like an engineer would like be more like like language agnostic maybe.
Yeah. I'm kind of curious. I'm assuming that you also use like pandas day to day very frequently.
Yeah.
So recently, Databricks, which manages, which has a lot of platform work built on top of Spark, came out with this thing called Koalas
Saw that.
that has
yeah.
like it's like a pandas-like API that sits on Spark.
Huh.
I want to check that out.
Koalas.
Yeah.
I love the name.
Did you go to Spark Summit?
I didn't,
Oh,
but
okay.
I watched all the talks, and
Yeah.
so that's where I learned about
Mhm.
Koalas
Alright.
too.
Yeah.
That's very cool.
Cool. Whew. I think I know what I hate the most: pager duty and waking up at 4 in the morning when things break.
Yeah, that sounds terrible.
Aside from that, I think doing the transformations and ingesting that data at scale is actually really fun. Doing real-time stuff, I'm really passionate about writing machine learning, real-time pipelines that can process like gigabytes, terabytes of data. It's scalable in like seconds. So I think that's a really cool part of my job. Yeah.
I think the part of my job that I enjoy the most is that satisfaction of when one of your model finally makes it live and like you can see it in the product. That's like amazing. My least favorite part of the job is kind of related to my favorite is when after you build that first model that goes into production, now you have to iterate on it and improve it.
Yeah.
And actually like those like making those improvements like little by little, like it's so hard. A baseline model can do good, very good, but then like you want to improve it, and then you try all these like crazy machine learning theories, and then like not seeing improve as much is kind of like painful, but I still like that part anyway. But a little bit more demoralizing.
I can imagine that. Kind of like what Justin was saying, my favorite part is definitely the real-time component of my work, where building out like real-time ML pipelines is like really fun. It's either the streaming side or the API side, doesn't really matter. Like when I can see it being used seeing ML models being used by users, at scale, seeing like the hundreds of thousands or millions of predictions that are taking place like every second or every minute, like that's an awesome feeling. And knowing that it's working well for our users too. So like when the data scientist comes out with like, 84% accuracy or something, like if I can say that the same thing applies in production, like that's a great feeling. Even though I didn't do anything for it per se, but like it feels really good. In terms of stuff that I don't like so much, that process that we were talking about earlier, that handoff between data scientists and ML engineers, like there is still a lot of friction in that, mostly because that back and forth ends up taking so long sometimes, especially when you have some new models. It's a baseline model, but still like you realize like, the data pipeline isn't built out for this, can't do this on production, or you run into like essentially like if you think about it, ML engineers have to try to take what the data scientists do and fit it into a box. And like sometimes it's way out of that box and it feels crazy or crappy to chop something off or compress it to make it fit in there somehow. But at the same time, like our job is to also grow that box in size so that more different things can take place from the data science perspective.
What's the handoff?
What's
like
the
is
handoff?
it like data scientists hand you off that model? But is it like a notebook? Like what's the how do they do it?
Yeah, usually it's a notebook. It's a location in an S3 bucket. Like here's the pickled artifact.
Okay.
And that's pretty much it. And then we have like several discussions about the code itself if it's not super well documented or anything.
Huh.
That happens. When you're talking, it also reminded me, whenever you ingest new data, I actually find a lot of friction trying to get data scientists to see the new data coming in and trying to understand how their data maps to maybe you have a canonical data format, like a format, that vocabulary that everyone talks about. But trying to create those transformations to something that data scientists can expect and use off of.
Yeah.
There's a lot of back and forth. I wouldn't say that I hate that part of the job,
Yeah.
but there's a lot of friction where they're optimizing for certain aspects or certain parts of their pipeline where we're optimizing for ours.
Yeah.
So there's definitely one friction point there, I'd say. Do you ever notice that in your workplace?
No, I'm just noticing that you guys all have frictions with data scientists. So I'm like, that's not good. No, I see what you're saying. I think there is the optimal way to do it, and then the desired output that data scientists. But I do believe data scientists should be able to do those transformations themselves. Prior to to building that model. So maybe like a recommendation that I have for you is to like sometimes push back a little bit on that data scientist. Do you really need that, or can you just like on the fly do it, or like maybe you do it in Python? Like if it's possible, then it doesn't have to be in the ETL pipeline or something. But yeah, I do not have any recommendation.
No,
I
I think
feel
it's just such a new thing.
What it feels to me is that if I build a model and I send you like a notebook, and like now you like build it, like it feels like a lot of like redundant work where I build a model and then now you're like gonna rebuild it.
I wouldn't say it's rebuilding.
Okay.
It's more of just saying, okay, where can we optimize things here?
Okay.
So for example, I want a single request on my API to take place in less than 50 milliseconds.
Yeah.
But if your model for a single prediction is taking 3,000 milliseconds, my job is to optimize that code so it comes down to 50 milliseconds.
So let me ask you this question.
Yeah.
How many times the model that the data scientist builds, that actual model, which is Pickle or whatever, is the actual final model that goes live? What percentage?
So the pickled model, I want to say it's like 80 to 90% of the time actually.
Oh, that's
the
impressive.
pickled artifact.
Okay.
Because that's just generally the way we like to do make the pickled artifact. We want it to just be like a TensorFlow object, not even a TensorFlow pipeline, like an object.
Okay.
So it's literally just the vectors that are needed to make the prediction. In terms of the pipeline, that might change by 80-90%, where we might work on, okay, you performed one hot encoding in this way, we know of a more performant way of doing it, or you performed this text transformation, like faster way of doing it, or how can we shorten this pipeline but still get the same results that you're looking for. Different things like that.
Great.
You have to love data. Like you have to love looking at it.
That's true.
You have to realize that your data is never going to be like 100% correct. Almost never. Like even if you get a perfect pipeline, like you're still going to have your bad eggs in there. You have to look past it, but realize and still have some sort of threshold of like, okay, this is getting too bad, and growing and having those discussions. But then being able to translate your own love of data, maybe from a technical perspective into more of a business perspective as well, because the people that you talk to are PMs or product people or business analysts. The people that you talk to might be business analysts as well, or engineers, and same thing. We have to be able to translate that back and forth. I think that's like number one. If you have that, then like you're well on your way.
I think a good data scientist should be very creative, because I think this job is a very creative job, as in like there is no one single solution to the problem, and so like a data scientist should like be able to think outside of the box. When there is not a clear solution, there is always like some creative way to get there. So I think that's a very general answer, but I think that should be something that you embody, like creativity.
I see. For data engineers, I would say someone who is a logician, someone who likes thinking logically, can also look at the big picture of how different things interact with each other. I find that the ones that are really successful are those that don't kind of nick at every small point, but can keep on moving and think logically on like prioritizing which is more important, which problem to solve is most important. Things like that, I think, is what makes a good data engineer, and people who like their job more too. Because with data, you can always go deeper into the data. You can nitpick at every small little point, or like, you have terabytes of data. You can find like one bad record, but are you going to optimize your entire system for that one bad record? So things like that. Okay, I feel strongly about this. I think data scientist has the coolest job. They don't have to care about production. Like,
I agree.
they don't have to care about production.
Yeah.
What?
Like
But I think the production is fine.
That's someone who's never been on PagerDuty before.
Someone that doesn't, have to deal with things going down all the time. And then when things go down, the first person they look at is us too, probably.
Okay,
And
well, I agree. I have the coolest job.
Okay. At least we're unanimous on this.
Yeah, I'm glad we're unanimous on this.
Yeah.
Yeah, and like the whole creative thing that you just talked about, like I agree. It's fun thinking from that perspective about different problems. For sure.
I agree. And something about being a data scientist that somehow you never have enough data, that you always want more. So like coming to you like, oh, can you have more data? Can you give us more granularity? Like you just want more and more and more, and like you just want to swim, and it's just very exploratory, very very like creative. So cool. Yeah, I'll take that. Yeah.
You go ahead.
Oh, how come I'm not a data scientist?
I know why I'm not, because I suck at math. I cannot do linear algebra and matrices for the life of me. Like, put a gun to my head, I would not be able to solve a system of equations. So I just never found that interest. So I took a more data-oriented route. I like the problems with that, with just solving problems logically, rather than getting into the weeds of math. What about you?
That makes a lot of sense. For me, so I've actually done a good amount of data science consulting work. So I have worn the data scientist hat, and I really enjoy it, which is why I can definitely say it's definitely more fun. But a reason why I'm an ML engineer too is I understand the importance, I think, of being able to take something to production. And in my previous roles, I've worked as a data engineer as well. So having the opportunity to have worn all three hats, I think gives me a lot of experience to maybe one day, far into the future, maybe have my own product where I have been able to, since I've worn all those hats, I have that wisdom or experience to, lead an engineering team across those different, lines.
Yeah, I do agree that wearing all the hats definitely brings a lot of value, and it's really fun. And to your point, I don't know if you're familiar with Jeremy Howard. Howard? Hopefully I pronounced it well. Well, he teaches data science in a way that he basically tells you that you don't need to go into a lot of the math or a lot of the details, and just learn by doing. So although math is kind of the core of data science, you might not necessarily have to be a master.
Okay.
So don't
Interesting.
Discard data science because of the math. Even
I
though
Really?
I always love math.
Okay.
Even though I always love math, but I'm like, did I say that my part of the job is 70% Python SQL? I never said there is math. I'm not solving equations.
Okay.
I'm not solving equations on my day-to-day life. So, yeah.
What about papers? Do you guys ever have to read papers on how to implement an algorithm with some math?
I do read them, and let's be honest, sometimes those papers are overwhelming with all the math, and hopefully if you can read between the math and understand it, and I think it's just getting an understanding of what's doing. So some math, I'm not gonna lie, it's required, but you can also understand the concepts of the papers, or instead of going to the papers, read blogs. There is a lot of companies doing a lot of cool blogs.
Yeah.
Okay.
With code snippets, and you just understand the concept and then you apply it.
Okay.
Yeah, and there are blogs that summarize papers too, which is if you don't want to read the paper, you read the blog about the paper, and that's also good enough.
Yeah.
What?
Yeah.
Yeah.
Okay.
At the end of the day, there is
I didn't see
academia and there is the real you know, the real
Right.
work.
Yeah, the
Practical
application side
Yeah.
of things. Yeah.
That's cool.
Yeah.
Let's take a look into that one day.
Yeah.
We'll see.
Hey, I'm Eliza from Springboard. We're an online school that gets you hired. All of our courses come with a job guarantee, one-on-one mentorship, and real-world projects. We teach UX design, data science, and machine learning engineering. To learn more, check out the links below. Happy learning!